Okay, so the second part of confidence intervals. So in the first part, we actually kind of set the basic building blocks of what a confidence interval is. And not that we've talked about how to find a confidence interval. We did talk about how to interpret one once we found a confidence interval, okay? All right. So now we're going to talk about interpreting a confidence level, which is totally different than interpreting a confidence interval, okay? Confidence level, okay, so the 90%, 95%, 99%, okay? So the common misconception that people have is that if I say there's a 95%, my confidence level is 95%, and I give them a confidence interval, that means that 95% of the time, I'm going to have the true parameter, whatever it may be, is going to be in that 95% of that time within that interval. So that is the common misconception, and that is not correct, okay? And a lot of times the tests will ask questions based upon that, predicated on that, trying to get you to say that when it's not true, okay? So what exactly does it mean then? What exactly does it mean? So let's look at that activity there. There's an activity on the bottom of page 499, okay? And it's an applet, and I'm not gonna, actually, I highly encourage you to, again, visit this applet and go ahead and play around with it. But let's go ahead and just read through it. So in step one, it says go to the applet, use the default settings of confidence level of 95% with sample size of 20, and it does the graphs. Then click sample and then flip the page on page 500. It says number 2, click sample to choose an SRS and display the resulting confidence interval. And then 20 values are marked with yellow dots, okay? And then if you look there, it shows you the sample. And it shows you the confidence intervals, and it shows you the black ones, and there are one single red one. The single red one there indicates that that is an interval that actually did not capture the true mu there, the true mu being that green line there in the middle, right? There's a mu and there's a green line that goes all the way down the bottom. That green line is not captured, in other words, does not intersect with that red interval. All the other black intervals there it intersects with that green line. In other words, it captures the true parameter, okay? So as you can see, out of the 20, one of them did not capture, which means that there's a 95% chance, right? That 90%, the confidence level is 95%, meaning that 95% of the time, the actual interval will capture the true parameter, okay? So in other words, if that confidence interval was larger or longer, so if you make those longer and go increase it to 99%, the lines themselves are going to be longer, right? We will have a larger confidence interval, okay? We already talked about that. We talked about the difference between 90%, 95%, and 99%, how a 99% confidence interval would have to be longer than a 90% one, right? We talked about that. Okay, so let's go to page 501. On top of page 501, it says interpreting a confidence level. Okay, now again, it's a confidence level, not a confidence interval here, right? So to interpret a confidence level of 90, let's say if we were to select many random samples from a population and construct a 90% confidence interval, using each sample, about 90% of the intervals would capture the parameter, okay? Again, that's what you're looking for. If you go down the bottom of page 501, it says in a big red dot, the confidence level does not tell us the probability that a particular confidence interval captures the population parameter, okay? That's what I started off with, okay? It doesn't mean that 95% of the time that the true parameter is going to be within that interval. It means that 95% of the samples or the confidence intervals that you make will contain the true parameter, okay? All right, so let's go up to the example there. It says 2 weeks before the presidential election, a polling organization asked a random sample. Okay, this is the 0.48 to 0.54. 95% confidence interval, interpret the confidence level. Okay? So it's a 95% confidence level. So it says, if we were to select many random samples of the registered voters and construct a 95% confidence interval using each sample, about 95% of the intervals would capture the true proportion of all registered voters who favored candidate A. Okay, all right. All right, flip the page and it says, what affects the margin of error? Well, there's only two things that affects the margin of error. If you flip the page to page 504, it's in that green box there. Okay, we actually talked about both of these, okay? We actually talked about both of these, all right? The first one says, in general, we prefer an estimate with a small margin of error. The margin of error gets smaller when the confidence level decreases. Okay, again, when the confidence level decreases, you're gonna get a smaller margin, smaller interval, right? You get a smaller margin there, okay? So when the confidence level decreases, that happens. And also, we already talked about, if the sample size, when the sample size increases, the more you sample, the less margin of error you're going to have, because you're going to be more confident. You're going to be more confident with that actual margin. Okay, so we've talked about those. And then on the bottom of that, it shows you. Okay, it briefly introduces you on how to do or how a confidence interval is constructed. Okay, so it says to sigma x bar. So this is actually a mean here, right? So you have a mean here, and you have this. So you're going to have the actual parameter here. Well, actually, no, this is not the parameter. This is the point estimate, right? This is the point estimate. This is the point estimate. Point estimator, right? And then you're going to have here what is called a critical value. This here is going to be your standard deviation. Okay, this is nothing more than the standard deviation of the sample. Okay, standard deviation of the sample. Okay, so this is the value that we know. Okay, this is the value that we know. Okay, so setting this is what actually sets, so setting the critical value is what determines or how the confidence interval changes, right? Because these two are already set, you already have these. So setting this is what controls the confidence level, whether you're at 95%, whether you're at 99%, whether you're at 90%, okay, all right? So if you go to page 505, there's a definition there of the critical value. It says the critical value is a multiplier that makes the interval wide enough to have the stated capture rate or the stated confidence level. So the confidence level is determined by the critical value, okay? All right, so. Well, there's a red dot there also on page 505 that says the margin of error does not account for any sources of bias in the data collection process, okay? If there is any bias if there's any bias, right, this itself is no good anyway, right? Nor is this any good. Your point estimators are no good because there's already bias that's been introduced there. So it doesn't really matter the margin error or anything like that. It has nothing to do with that, okay? All right, so let's go to the example there on bottom of page 505. As part of a project about response bias, Ellery surveyed a random sample of 25 students from her school. One of the questions in the survey requires students to state their GPA aloud. Based on the responses, Ellery said that she was 90% confident that the interval from 3.14 to 3.452 captures the mean GPA for all students at her school. A, explain what would happen to the length of the interval if the confidence level were increased to 99%. So to increase the confidence level to 99%, to have a higher capture rate, your confidence interval would have to become wider, right? All right, we talked about that. B, how would a 90% confidence interval based on a sample size of 200 compared to the original 90% interval, which was constructed with what, 25 people, right? So if you raise the amount of the sample size, if you raise the sample size, again, the margin of error will decrease, right? So B, the confidence interval would be narrower, or you would have a smaller confidence interval because of the increased sample size. C, describe one potential source of bias in Ellery's study that is not accounted for by the margin of error. And what is the bias? Anybody? The bias is the fact that she had them say it out loud, right? So that everybody else can hear it. So there's more chance for incorrect data, i.e. lying about my GPA, right? Okay. All right, so that's it. We're done. Okay, so we are done with 8.1-2 now.